It's recorded, right? Oh, yeah, okay.
Okay.
Okay, so to
Hold on. Before that, let me open
oh yeah,
what is it, the website as well.
official. Okay. Oh, I thought you were going to open the video. Like, is this going to be an official video tutorial?
No lah. Send me the link to download this thing.
Yeah, yeah, yeah. I'll send it in the chat.
Mm-hmm. Okay.
Okay, so I'll start.
Okay. Let's start.
Yeah. So this is the Copernicus Climate Data Store, and the link that I gave you is directly to the download tab. So on this tab, you are able to download any kind of data that you need. Usually, if we're doing the assessment for wind and wave data, we check several data here. So the 10-meter U component of wind and then 10-meter V component of wind. And then there's also the mean wave direction. These are the ones that I usually download. And then again, this is pretty accurate only for the wind because like for this one, um, usually what I do is I download the wind data and then I do wind hindcasting, sorry, wave hindcasting using the wind data. And then there's the mean wave direction, and this one is only for validation. So, within the assumption that we are doing like wind generated waves, the direction from the wind, like after we do the wave hindcasting, the direction should be the same as the mean wave direction. So this is only for validation purposes. But for now,
Why
yeah.
don't we just straight away use that mean wave direction? Why do we have to do this validation though?
Because like it depends. If you want to check which direction the wave is going, then you can just download that. But you cannot get the height of the wind. Okay, you actually have this one, the significant height of combined wind waves as well. But the
Mm-hmm.
problem is, I mean, I think you can look this up as well. But the amount of data that they have for the wind data set and the wave data set is different. It's way more, how do you say it? What do you so like the grid for the wind data is tighter than the grid for the wave data. Does that make sense?
Also, tighter means more refined.
Let's say that you have a certain uh location, right? A certain coordinate. I think we tried this before in the South Bali project.
Mm-hmm.
When we check the sea states, you remember when we were talking about that? Oh yeah, the grid for the wave is
Mm-hmm.
like it's pretty big, so you
Mm-hmm.
can't. It's assumed that for the whole grid, the wave direction is the same, the wave height is the same. You remember that?
Remember correct.
Yeah, but the wind one is way more tighter, so it's more accurate than the wave one. So
Okay, got it.
usually we do wave hindcasting from that. But if you want to do just like a quick sense check, similar to the one that we are doing on sea state, you can actually download this one.
Okay.
Okay,
Okay, but let's
so
say at this
mhm.
point, let's say we can we like download that one, another one.
Oh yeah, yeah, sure.
Okay, okay, and
Okay, so
then
like
okay,
for
okay. And
yeah.
okay, have you tried to download that temperature, the sea temperature there?
I've
Okay,
never done that, but you can do that.
what does it mean by 2 meter temperature and sea surface temperature? Do you have any idea on that?
No, I haven't tried looking into that one, so I think we can look it up together after this.
Maybe 2 meter temperature is 2 meter below sea level. What do you think?
Mm, I have no idea if it's 2 meter below or 2 meter above the sea level.
Okay,
But you also have like sea surface temperature. Yeah, I think
okay,
we can look this one up
okay.
after
All right.
this.
Okay.
Okay, so for this tutorial, let's just try to do this ones first.
Mm-hmm.
The wind components and the wave direction and significant height
Mm-hmm.
of combined wind waves as well. The whole variables are over here, but you can also check like the sub variables here. Yeah, there are just like a whole lot of data sets.
Ah,
And
okay, okay,
then,
okay.
yeah, ocean waves. See, like there's a lot of data here.
Got it. Understand.
Mm-hmm. Okay, and then the next one is the time period, which will create this data, which will turn this data set into a time series. So you have the year, the month, the day, and the time. I told you yesterday when you asked, oh, what is the time steps, yeah, the time
Mm-hmm.
steps for this
Correct.
data. Yeah,
Yes.
the time steps for the data, like the smallest one is the time here. So that's my answer. It's like an hourly data, and that's the best that the Copernicus website can provide.
Okay.
Okay, so like for example, I'll try downloading the 2025 data. Usually
Mm.
I don't try to download the latest year because I get 2026. It's only in April in 2026 and it wouldn't be a complete what do you call it? A complete data set yet for a year. So usually when I do my analysis, I do like 10 years up until 2025 unless the clients ask to have the latest data up until 2026, then I include that.
Okay.
So let's try for 2025. We're going to download the data for 1 year. So I'm selecting all the months, I'm selecting all the days, and I'm selecting all the time.
All the time means that okay, 1 hour hourly, okay, hourly.
Yeah,
So
hourly
let's say
data.
if we just skip like 2 4 means that we are taking 2 hours, right? 2 hours of time step,
Yeah,
right?
yeah,
Like if
like
we
this.
yeah, okay. So this is
Mm-hmm.
really the 2 hours, right?
Yeah, true. So
Okay,
it
got it.
depends.
Okay, got it.
Yeah,
Okay,
but
before that, when ICER did that validation, they also used 10 years, right? Or what? Or 20 years?
yeah,
10 years.
in our previous Metocean report, the analysis that they conducted is for 10 years,
Okay, got it.
as far as I remember.
Okay. Yep.
Okay, and then next there's the geographical area.
Okay.
And this one is actually pretty important
Mm-hmm.
because we need to select the boundaries for the data that we are going to get. And
Mm-hmm.
for this one, we would need to use Google Earth.
Mm-hmm.
By the way, is Google Earth showing on your screen right now?
Okay, got it. Yeah.
It's showing, right?
Sure, yep.
Yeah, okay. So for example, I'll try doing this one for the South Bali one because
Mm-hmm.
we tried doing that before. Yeah, FSRE South Valley. Okay, so let's assume that we are trying to get the Metocean data for this area,
Mm-hmm.
and then we have this grid over here, right?
Mm-hmm.
Oh, sorry. Yeah, this huge grid over here
Mm-hmm.
that is going to be the boundaries for the Metocean. And what I do is just like check the properties. Oh wait, it's not here. Sorry. I mean, we can just like do this and then check what is the northern boundary, like latitude, longitude, and then the west and east boundary, and then we'll just input that into the Copernicus. So, for example, let's try doing this one. It's like 8:38. So we'll go back to Copernicus. Just do it like this, yeah. It's like 8:38. And then that's the
Why it's minus, yeah?
because it's south. Yeah, so it's like the latitude is 8:38. Wait, on the northern side it's like 8:38, right? Eight
Okay.
degrees, 38 minutes, but it's in the south. So that's why I'm inputting it as minus 8:38. If I'm not mistaken. If I'm mistaken, then please delete this video. And then this other one is minus 8:58. Cannot be less than 0.25. Okay, so we can like do this and then minus 8.6. And then we'll do the west and east boundary. That would be 11510 and 11540. So like 11510 and 11540. Okay. So this is the sub-region. Okay, again, because we've tried to do this against the coordinates that we have on the Google Earth. So I inputted the boundaries for each of the north, west, east, and south boundaries. And then I think, do you think that's pretty clear?
The what?
Do you think that's pretty clear on
No, yeah,
how
okay,
we are?
okay, yeah, pretty clear. But when we define these coordinates, right?
Mm-hmm,
Can we validate it? Can you see in Copernicus is our
mm-hmm.
location right or wrong?
In Copernicus, no, but
Mm-hmm.
you have to visualize it after you get the output. So that's actually the brute force method that I described to you on this work, because we cannot actually see where is the
Mm-hmm.
sub-region these numbers are. We have to check after we get the data.
After we get the data and
Yeah, and then we download the data and then we have to check if the coordinates are correct. Something like that.
okay, got it. Can you go to the that question mark at the for the
This one.
sub-region extract? Okay, select a region by providing its limit on latitude. For areas smaller than the grid cell upon location, please use the relevant post-process error 5 time series datasheet for areas smaller than the grid.
Hmm.
Any idea is that?
No.
No, it's okay.
Because I think like in this description, it's describing like for example like point locations, right? Point
Mm.
locations means like just one coordinate. The thing is like usually when I extract this data, I use the Python code to actually select that one point.
Okay.
So the output from this Copernicus dataset is still like it has its own coordinates and it has like a whole lot of data, which I then extract using my Python code.
Okay, got it.
Yeah. Okay. And then I'll continue to the next one. That is the data format. And for this one, we are using the NetCDF4. But there's an issue with this one. So if you look at the right hand side here, we have the request size for the request validation. And then when I click NetCDF4, usually the request size exceeds because the format is significantly heavier than the grid format. And this is actually an issue. Usually when I do this, then we have to make some modifications to the data sets that we are um, requesting. And usually what I do is I try to download the dataset separately because the request size is too big. So probably on this request, I'll just request for the win data
Okay,
and the
understand.
request size reduces. Again,
Understand.
yeah, again, this is like the brute force part of doing this analysis.
So if
So
it takes 10 years, so it will be larger, right? I mean, the request size will be
yeah.
exceeding, right?
So that's why like if I'm doing 10 years, the brute force part is to request this 10 times.
Yeah.
Like inputting the exact same geographical area and doing like the same thing over and over again, just changing from the years for 2025 to 2024 and up until 2016. Yeah.
And
Again?
why we are not using the grip?
That is actually a good question, but I would say, like personally, because I am not used to that format, because I did not learn how to use that format. But I think if we can develop a method to use the grip format, that would be good as well.
Can you open the premium and ask what's the difference between grip and net
Okay,
CDFO? CD was it?
let's see the
CDFO.
F4.
Mm.
For Copernicus data. Graded binary.
Highly compressed, very small size, so independent. Because specific. Harder to expand the metadata is less with the extra setup. Okay. Ah, okay, okay, got
Mm-hmm.
it.
Yeah, so basically it's easier to work with, but
Yes,
significantly heavier.
correct. Yeah, means that if you can see the direct comparison bottom there, you see the structure, the message base. This one is data set with arrays and metadata, easy to use, easy reasons. Yeah, okay, yeah. I
Mm,
think that's the good.
yeah, okay, so we'll go
Okay,
back to this one.
okay. Now we understand that.
Yeah.
Previously, we don't understand. Now we
Yeah,
understand.
true, true, true. Okay, so that's a reason why we are using NetCDF4, and that's because it's easier to work with. But again, like the downside to using this one is it's significantly heavier, and it would take some time as well to request the data. So probably when I did this for the South Bali FSRU, I think it took me like 10 minutes to obtain one data. And that would mean like for 10 years data, I would need like 100 minutes, around like 2 hours just to request the data.
Okay.
So yeah. Okay, so I'll move on to the next one is download format. I think this one is pretty straightforward. Zip or unzip. Let's just try zip. Usually I just do zip. Because I think like usually there are more than one data here. But I kind of forgot. But yeah, again, this is just like download format. And then finally, terms of use, and then um, oh man, I haven't logged in. I need to log in first. Give me some time.
Login is free, right? So you
Yeah, yeah, yeah. I already have the. Oh yeah, I don't have to. Now I can do it. Oops, sorry, wrong screen. Okay, now I'm back. Yeah, so I have a login now. And, but once you get the hang of it, I like it's pretty quick actually. Like as long as you remember the coordinates for this one. I forgot. I forgot the west and east boundary. Oh yeah, I remember. Like 115.1 and 115.4. That's CDF, zip, and then submit form. And that's it. Now we have the request data, like my request. So here you can check the status of the request, and then you can actually see um, the data that you requested. So the days, the sub-region extraction, the time, year, month, variable, and everything else. So basically, after getting to this part, you just need to wait until the status is changed, not to accept it. So yeah, there are four kinds of status here: accepted, running, successful, and failed. Once the status is successful, you can download the data immediately.
so now I have to wait until it's successful, right?
Yeah, like around like
Ha.
10 minutes.
Oh, okay. All right.
Yeah, that's it actually. It's pretty simple once you get the hang of it.
And then once you have downloaded it, can you show me the file?
Oh
Okay,
yeah, I can
as yeah,
actually show
previously. Yeah.
you yeah, one of the files that I've downloaded.
Mm-hmm.
Let me check it. Ocean. Time. Okay, so okay, this is the example data. By the way, this is on my Python folder. So what I've did here is categorize the sorry, the datas based on the format, and then the yeah, the file formats before and after I put it into my codes. So basically the first one that you would get from the Copernicus data is this NC file, because this is in NetCDF format, right? So
Mm-hmm.
as you can see here, I've downloaded all the data from 2017 up until 2025. There's also the wave data here, but what I've actually processed is the wind data only. And then for this one, I need to open my VS Code first. Uh, the steps after this one is to use the Python code that I sent to you yesterday. So you can see here.
Mm.
Yeah. So what the Python code does is actually import the NetCDF, and then um, on this one, we try to find the data set that we are using, and the code here is to find the path. So for this one, I only need to change the name here because everything is already in one folder. But to be precise, you would need to copy and paste the path over here
Mm-hmm.
into the code and then change it with the file's name. So the Python code detects the file that you are referring to. And
Can we set the, for example, okay, because now you are post processing one by one, right? For example,
mm-hmm,
2000 or
yeah.
2016, whatever. 2000,
Mm-hmm.
can we the data set? Can we rewrite the code so that the data set read all .nc
In one
files
folder.
in one folder?
I think that's possible, but I would need some time to develop the code first because I haven't tried that.
Okay, it means that I mean for the when you're free, yeah,
Mm-hmm.
again this is not a development already, but when you're free, because I was thinking of if you do one by one, it will be like
Yeah,
one by one, right?
true, true, true.
Yeah.
But I think like even though that we haven't tried doing it like all in one set, I think this one is pretty straightforward as well because all I need to do is to change like 16 to 17, 18, and so on, and the results are pretty quick as well. But I think like we can try to develop up until like so the code recognizes all the data in one folder and then directly process it.
Sorry, this is out of the topic of this meditation. When you have this visual, what do you call this?
Yes,
Visual
code.
VS Code, VS Code. The, because we need sometimes we need to do this pip install the package and remember.
Yeah, true.
Can we do this in our laptop?
Yeah, I do it on the terminal over here. But there's also a problem with this one in which the Jupyter Notebook extension, it cannot be installed on this one. And I've requested the IT to check on it, and they can't do it as well. So that's why I ended up using the Jupyter Notebook on the browser version.
Yeah, I know
This
because
one.
even for my personal laptop also because the installation folder sometimes different when
Yeah,
they try,
true.
right. Okay.
Mm-hmm. But on my personal laptop, I use VS Code, and the extension for the Python and Jupyter Notebook is installed correctly on the one.
Mm-hmm.
And usually, what I do to make it like super simple is I put it on a local disk, like on a local as a local file. So, for
Mm-hmm.
example, for this whole Python code that I'm doing on my work laptop, sorry, on my work laptop,
Mm-hmm.
I'm putting the Python code on the downloads file. I know that it sounds pretty weird, but that's the only one that I can find that is not connected to the cloud. Because if I do it on the documents data, it's connected to the cloud. But if I do it on the downloads folder, I can make sure that it's local and
Mm-hmm.
it would just be more seamless to work with.
Okay,
So yeah,
understand.
that's why I put my Python code on my downloads. But on my personal computer, I put my Python file on my desktop.
Okay, understand.
Yeah, and that's way more simple.
Okay,
Yeah.
enough.
But,
See.
I'm not sure if I should be explaining
No, no,
all
no, no,
of
no,
this,
no, no, sige, no, 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 no.
but I'll just explain the ones that you need to pay attention to.
Mm-hmm.
Okay, so it's this one actually. To change with the desired coordinate to be extracted. This is the one that I explained to you earlier. So because the NAT CDF data, it's kind of like a spatial data, in which like you have the metadata for all the points within the boundaries that we had set. So what you need to do with this Python code is to pinpoint one coordinate in which you would like to extract the metadata.
Yep.
And so that's why you need to change this one. This one is like just a random point. If I'm not mistaken, I inputted the FSW coordinates on this one. Like in our analysis, we would say that it's P1. This is the
Okay.
coordinates for P1
Okay.
basically.
So can you open the Google so that we can check that
What?
the side by side? You go open.
Oh, yeah, yeah, yeah.
Okay.
This one. Mm, yeah, I think like I can just like edit this one with minus 843 and then 115.15. Okay,
Okay.
so okay, and I don't think that we have to change anything else. So basically, what this code does is after we input the coordinates to be extracted, there it's going to do the calculations here and there, and it's going to export the results in like a CSV file.
Okay.
So what I do is just I run it, and then yeah, it works. The virtual environment and all, and then wait, oh wait, that's an error here. Mm, 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 mm. Oh yeah, I think I need to update the directory. But yeah, for the purpose of this tutorial, uh, let's say that the code works.
Mm-hmm. Let's say it's okay. It's okay.
Yeah, yeah,
Yes.
yeah. I'll edit it in a bit. Okay, and it's going to, yeah, it's going to create these outputs. For example,
Oh, means that
win pipe.
now you run separately, right? So you just change the name file at the
Yeah,
top one, and then you run, and then you save
true.
CSV, run save.
Yep.
Okay.
And then what I actually do afterward is to like combine everything into this one file. But yeah, after that you have these results. And I think this one is pretty similar to the screenshot that you showed me yesterday, right?
Yes, understand. Yep, correct.
Yeah, after this, like we need to do, if required, we need to do like further post processing. The like if you want to get the results of this wind speeds and the direction, we can do that as well. The ones that I try to develop is to like have a ready to use Excel sheet, but I haven't had the chance to develop that yet. But I think like it would be pretty seamless if we can do that. But yeah, that's
So
the results.
when you said you're going to create that Excel sheet, what is the findings and the output, expected output?
The resultants of the wind speed
Resultant.
and
Okay.
the direction, and
Okay.
then the direction we check against the mean wave direction that we have downloaded from Copernicus.
Okay. Got it.
Mm-hmm.
So it's not ready yet.
Yeah, that I'm not. I don't have that yet.
It's okay. No problem.
Mm-hmm.
Okay.
And that pretty much sums it up. Other than that, I think I only have the data for the, yeah, the Winrose plot. Yeah, so the Winrose plot code is pretty much similar to the other code. So I wanted to change the file path here. Basically, oh yeah, let's just go back to this one. So again, we have this kinds of formats, right? First
Mm-hmm.
one from the Copernicus, we get the .NET file, and then we
Mm-hmm.
convert it into CSV. If
Mm-hmm.
you want to, we can convert it to Excel,
Mm-hmm.
but I didn't do that, and then I went straight to creating the WinVerses. So what you need to do is just like follow the instructions here. First one is to change the file path directory here, and then use that,
Mm-hmm.
and then change the plot title, blah 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 blah. I think this is just like for the formatting, and then replace the output Windows file path. So where do you want this to be saved, basically? And then we just like run all cells. Yeah, so this one it works pretty well. So here after doing the calculations, it would show the the one that we just discussed. So I didn't do the calculations directly on CSV yet, but for the purpose of this win and wafers, eventually I did that as well. So this is the code to calculate the wind speed, and then this one is for the wind direction, but it's like in terms of 360 degrees. It's not in now in
Mm-hmm.
northwest, east, and so on, so on.
Mm-hmm.
And then yeah, the Winverse is just there. You can actually change the colors as well if you want.
Okay, that's good. First of all, is this saved in the DED folder?
Not yet, not yet.
Is it okay for you to save it into DED
Yeah, yeah, yeah.
for me to because I got some idea to write how a comprehensive, a complete uh, Python codes.
Mm-hmm.
Still in the idea, so I still need to use the premium to help me with that.
Yeah, okay.
So that with one go, you got everything in one go.
Yeah, yeah, yeah. I think
Yeah,
that would be great.
actually, yeah, actually, this is good. Because you're doing the good one, it is step by step. This is very good. And when when you are a bit, you are sorry, when you understand everything, so you need to go like one click automated. So that's it,
Mm-hmm.
right?
Mm-hmm. True, true, true. I think we can do that. The only reason that this happens separately is because I couldn't install the Jupyter Notebook on
Understand.
my, yeah.
It's okay. Actually, I have my own laptop in here, so
Yeah, yeah.
I'm thinking of now this morning I have some free time. I will just do it then.
Yeah, okay. Uh, yeah, so you want me to update this into the DAD folder?
Yeah, yeah. Just
Yeah.
save it into the folder.
Okay, I'll do that in a bit.
Maybe, and then the thing is, you have to make sure your previously your Python code shows some error, right?
Yeah, but the
Uh,
errors that was showing and the previous code is like a path error instead of the code error. So
a
I just needed,
path of Python
yeah,
path.
yeah, yeah. It just
Oh,
couldn't find the file.
yeah.
Yeah, yeah, yeah.
Okay, all right. I think okay, this is good. Okay, so this is for the wind speed, right? For the wave, you for
Not
the
yet,
like wave height, not yet, right?
not yet, because
Okay.
it requires the wave hindcasting first.
Mm-hmm.
Mm-hmm.
So, but if you want to get like a high level one, you can just download the one, right?
Yeah,
I mean the big
the
grid
big
one,
grid
right?
thing.
Yep.
Yeah. Mm-hmm.
Okay. All right. I think that's all, Audrey. Let me try to understand first. You put the files in the DD. Let me download and then
Mm-hmm.
try to do by my own first.
Yeah. Okay, great.
Okay. Thanks, Audrey.
Thanks, Jiten. Bye.
Okay. Bye.